All right, everyone, welcome to the next video. In this video, we're going to actually start creating our shellcode. And the first thing we're going to talk about is position independence and how we can gain an understanding of where we're going to be at in memory. You may have noticed as we were working with SC Launcher that every time we launched our shellcode, especially when we were attaching with debuggers, we didn't necessarily know where we were going to be in memory. And that's a common problem with shellcode, is that it'll be either injected into memory, not knowing where it's at, or if the program allocates memory, usually it just allocates a block of memory and lets the operating system pick the base address. So we need to gain position independence. We need to gain a position. Now, in order to do that, I'm going to start with a copy of the starting template. So you can do that just with a simple copy command. Video 6.asm, that'll be the video that matches up to, or the any resources that match up to this video. And we're going to start at the entry point with this call get EIP. We're going to define a label here, get EIP, and then we'll kind of end the label here with a colon. And then we're going to pop into EDX, whatever's on top of the stack. The final thing that we'll do is we're going to LEA, which is load effective address, into EDX, EDX minus 5. All right, that's all we're going to do in this video. So we'll assemble this, we'll step through it, we'll understand exactly what's going on. Now, what does call do? Well, call is going to call this label. So once we assemble it, the assembler will determine that the call location will be this label, which essentially is this pop instruction. What the call instruction ultimately does is it pushes the return address onto the stack, and that's the address after, after the call. Well, that's this location. So once we get to this pop EDX, on top of the stack is going to be this address. So now we have an understanding of where we're at in memory. From there, we're going to pop what is on top of the stack, that address, into this register, and then we're going to use LEA essentially to do a subtraction. So I know the calculation beforehand, but we'll actually count the number of bytes here in just a moment to say, okay, take this address, because this address in EDX, once we get to this location, this is going to be 5 bytes from the beginning of our shellcode. So we'll subtract from that and then move that into EDX. So LEA can be used for basic arithmetic. That means that now all of the references relative to EDX in our shellcode will actually start at the beginning of the shellcode wherever it's at in memory. Okay, maybe that doesn't make total sense yet, so let's step through it. Let's save the file, and we'll assemble this using NASM. So video 06.asm, that will create the video 06 file. We don't want to open that. Now we can use SC Launcher. Our file will be video 06. We'll create a PE file, and our output will be video 06.exe. Okay, so it looks like that was successful in creating. Okay, now we can use IDA to load our executable file. And what we should see here, yep, this looks pretty good. I'm going to turn on the line prefixes, and I'm going to turn on the number of opcode bytes. So pick a number here, it's variable, 7, 8, usually pretty good numbers. And here we can see now we have our call $+5, right? And that's the dollar represents the current instruction pointer. And if you look at that, that would be this location right here, this address, 401000, plus 5, 1, 2, 3, 4, 5. So that represents bytes. So it's saying call current location plus 5, which would be this address right here, opcode 5A, which pops into EDX. So this helps us to understand then that when we call that location, right, we enter, or we'll actually just, the execution will then go to this instruction. This will be on top of the stack, 401005, because that last instruction was 5 bytes. Therefore, if we subtract from that, by the time we're done with this LEA instruction, wherever the base address is for the allocation, then that's where we should be. So in this case, we're wrapped in a PE file, so we can set a breakpoint here. I'm going to close that, and I'm actually just going to save this as my default desktop. And now we can start debugging. Okay, I'll do very similar here. Toolbars, add the debugger command, and we'll save this as the default desktop as well. Okay, now we can step into this call. So notice down here in our window, this is our stack frame, our stack window. The blue indicates the top of our stack, or where, well, top of our stack and where the stack pointer is pointing to. So if you look at ESP over here, 19FF74, 19FF74. Now, when we step into this call, we'll see on the top of the stack 401005. So we'll step into that, right? Not only do we then go to that location, but now you can see on top of the stack is 401005. We're going to pop that into EDX. So now EDX contains our address. And after this LEA, EDX will be at the actual base of this region of memory, which in this case happens to be the beginning of the text section. All right, so let's step there. And now in EDX, you can see 401000. All right, so pretty cool. We can close IDA, and just to show you that this would work with a debugger, let's load this into memory. So we'll say dash pause, and we'll set the breakpoint ourselves. So let's load the shellcode using SC Launcher. Okay, there's our process ID, 7252. So I'm going to use WinDebug. Don't cringe, WinDebug's awesome. And we'll go to File, Attach to Process, 7252. Okay, well done. Attach. Okay, there we go. And then if we go back, you'll see that now our base, our allocation is at EA0000, right? Because in SC Launcher, I don't use a fixed address. You could try. Like I just use virtual alloc, I believe, and you could ask for a specific address, but I usually just let the operating system return whatever address it determines is available. So this will vary whenever we run, or should vary every time we run, or most times that we run SC Launcher. Okay, so that means that if we set a breakpoint on that address, we can now begin execution. We have to tell SC Launcher to let it go. And here we go, right? Now we're at our call. We can go over here and open up registers. Registers can be helpful to have. We'll dock that to the side. And now we can step into, I'm just going to use the DD command, so it'll dump dword ESP. And you can see now what's on top of the stack, EA0005, right? Because our allocation base was at EA0000. So that's going to get popped into EDX. So we'll step over that. You can see EDX now is EA0005. And after the LEA, now we have a pointer in EDX to the base of our shellcode. Why is this important? Well, because now when we want to reference additional regions of our code, for example, we're going to have some strings, we're going to have those checksum values, we'll be able to understand, and our shellcode will be able to understand then relative to where the image base, where our shellcode base is, how to find those resources, right? Because without that, without knowing where it is in memory, it's just going to know where they're located at a raw offset. So if that doesn't make a complete sense yet, don't worry, because in the next videos, by the time we get done writing our functional shellcode, all of this should come together and make perfect sense. Okay, so that is the basics on position independence. Now our shellcode begins with gaining position independence. That is, it has a reference to wherever it's at in memory. It doesn't matter where. And now we just need to be able to keep track of this value throughout the execution of our shellcode. Otherwise, we might have to do something like this again, and that can get kind of messy. So we're just going to keep track of this throughout execution of the program. Okay, next video, we're going to do our next useful thing, and that is we'll walk through how to use the get module address in order to load a DLL. So we're actually going to load a DLL that we're going to use. That's going to be user 32 because I want to call message box A out of that library, and that's not going to be loaded by default in our executable. So, and nor can we necessarily depend on it. If we're shellcode and we're running in a process, this method will either look for the DLL if it's already there, or we may have to forcibly load it. So we'll talk about all that in the next video. Okay, hope you're enjoying the series so far, and I'll see you all in the next video.